Using synthetic division, we can see we have a pattern. And this is a nice diagram because it shows you your patterns. When you're going vertical, up and down, you're adding. You're multiplying at the angle, at the diagonals. And that'll help you keep your pattern of your synthetic division. Now, when we divide synthetically, we pull out the coefficients of all the descending variables. You have to account for every descending variable. So if this is x to the fourth and then x squared, we're missing an x cubed. So that coefficient will be 0. So the coefficients we're going to pull out would be 1, 0, -10, -2, 4. And check. Your highest is a 4. So 4, 3, 2, 1, 0. It's got to go all the way down to get to the bottom. Now here's your coefficients here. This is a nice diagram to use to do your synthetic division. So now when we get to here, this is a factor. So we're going to set this equal to 0. The leading coefficient must be a 1 or we'll have to factor it out. Very similar to the way you do the complete the square. The leading coefficient has to be 1. So we set this to 0 and we find one of our maybe roots to be -3. We put that on the outside. So here's all your coefficients and then we follow your pattern. First thing we do is bring down the 1. Diagonally we multiply. -3 times 1, -3. We add down. -3. We multiply diagonally again. -3 times -3, 9. We add down. -1. Multiply diagonally. -3 times -1, 3. Add down. +1. We multiply again. -3 times 1, -3. Add down. We get a 1. Now, this guy, this last one, box this off. This is your remainder. If your remainder equals 0, then you have a factor. If your remainder is not equal to 0, this was not a factor. And we have a remainder. So to pull out these are the coefficients of your answer. Start by taking the regular division and look at the leading exponents. We have x to the fourth over x. So when we divide, we subtract. So that means we're going to start with an x cubed. So this would be x cubed, then x squared, then x to the 0, which is nothing, x to the 0, and then your remainder. So we're going to get x cubed minus 3x squared minus x plus 1. And here's your remainder, plus 1 over your divisor. This is your synthetic division. Now, if you were to multiply this answer by x plus 3, you would end up with what we started with. Okay, and if you can kind of see the front end, x times x cubed gives you x to the fourth. So it kind of gives you a little heads up that you're in the right direction. Now when we divide this one's leading coefficient is not 0, is not a 1. So we take this and we have to factor out a 3. Then we can set it equal to 0. And we're going to divide out by 3. And remember this, that we did the division by 3. So x minus 2/3 is equal to 0, and x is 2/3. So let's pull out the roots. We're going to divide by 2/3. We've got a 6, a -16, a 17, and a -6. And check. x3, x2, x1, x0. Bring down the 6 to start. When we multiply by 2/3, don't panic. It's divisible by, it's a factor of 6, so you'll be able to divide this out evenly. You're going to get 4. So when you're multiplying, you're at your diagonal, it's 4. On your verticals, you're adding down. So negative 16 and 4 gives you negative 12. Again, you're multiplying at your diagonal going to the right. So this is going to give you, when you multiply, and you'll get rid of your fraction this way, negative 24 divided by 3, negative 8. Vertical, add down. 17 and negative 8 give you 9. Again, 9 is a factor, factors out for 3, so you'll be able to do this. So 18 divided by 3 is 6. Add down is 0. This is your remainder. Since this remainder is 0, it does tell us that this was a root of your solution, or your solution to your equation. It is one of the roots. So our front end says x cubed over x. This guy's going to start with an x squared, then an x, then a regular. Now, because we divided by 3 over here, we have to divide everything over here by 3 as well. So our answer would be 2x squared minus 4x plus 3. And you can kind of see a better feel for this, because the 2x times the 2x squared times the 3x is giving you your 6x cubed. Just do your front and you kind of see it a little bit better. Now this situation is a little unique. This denominator here has a leading coefficient of 1, but we only used the last 2 places. So as we took the last ones and you ended up to see that they came out the opposite sign, we're going to do the same with this. We're going to do a double divide, and we're going to divide by 3 and a negative 1. So we're going to pull out your coefficients. 1, negative 2, 5, and then this last one is a 0 because there's no x to the 0. So we're going to make that be a 0 coefficient. So we're going to do a double divide by 3, negative 1. The first thing you're going to do is pull down the 1. And you're going to work your division this way. We're going to divide, but we have both of these to work with. So start with the outer one. And your diagonal. 3 times 1 is 3. Go to the right. Now do the negative 1. Negative 1 times 1 is negative 1. Go to the right. And stop. Add this one down. So negative 2 plus 3 is 1. Now start again with the 3. 3 times 1 is 3. To the right. Negative 1 times 1, negative 1. Once you reach this last column, then you stop. Add these down. This will give you 7, and this is negative 1. Okay, now, you started with an x squared on the bottom and an x cubed. An x cubed over an x squared gives you x. This is x1, x0. This is your remainder because it was doubled. So we've got x plus 1 plus, here's your remainder, 7x minus 1 over your denominator. And this is our answer.